Okay, we're going to take a look at how to solve the differential equations worksheet from class the other day. We're going to go ahead and start just with the first question. So for question 1, we have to find the general solution for the equation y squared over 1 minus x dy equals dx. So the general solution means our answer has to have a plus c in it. And to find any solution for a differential equation, the very first thing we have to do is we have to separate our variables. So let's group our variables. Now the very first thing that I see is I've got a y here and a y here, and I have an x down here in the bottom and an x over here on the right. So I think the easiest way to group my variables will just be to take the 1 minus x that's on the bottom and move it to the right-hand side. And I can do that by multiplying both sides by 1 minus x. It'll cancel out the one on the bottom, and it'll move it over to the side. So I'm going to multiply both sides by 1 minus x. On the left, I'm going to have y squared dy left over. And on the right, I'm going to have that 1 minus x and the dx that was already there. So I'll move everything over. And since there's nothing in front of the 1 minus x or any exponent on the 1 minus x, I don't technically need the parentheses anymore. Once I have all of my variables grouped, I can integrate both sides. On the left, I'm integrating y squared with respect to y, so I'm going to raise its exponent by 1 and divide by that new number, y cubed over 3. On the right, I'm going to integrate my 1 with respect to x. It's going to become an x. And my minus x here is going to become my minus x squared over 2. So its exponent goes up by 1, and we divide by that new exponent number. Technically, each side has a plus c, but we're going to group those plus c's into one giant unknown constant, and we're going to put those on the right. Just a big old plus c on the end here. If this was a particular solution, we would have to find out what that number actually is, but since we're just looking for a general solution, we're almost done. The last step for a general solution is just to get this y by itself, so I have a y equals equation. So I'm just going to undo everything that's being done to that y. So right now my y is being divided by 3. I'm going to multiply both sides by 3. On the left, I'm going to have a y cubed left over, and on the right, I'm going to have to multiply every single thing here by 3. So I'll start by multiplying x by 3. It gives me a 3x. When I multiply my x squared over 2 by 3, I can just put that as a coefficient in the numerator. So 3x squared over 2. And this plus c, if I multiply c by 3, it goes from being a constant that I don't know to triple that constant I don't know, which is still just a constant that I don't know. So I can still call it c. 3c is the same thing as c, so it doesn't change. The very last thing that I have to do to get y by itself is to take care of this cube root, this cube here, and I can do that by taking the cube root of both sides. So, and this will go all the way over to include that c. So the cube and the cube root will undo each other, and y will be the only thing left on the left. And on the right, I will have the cube root of 3x minus 3x squared over 2 plus c. And that's it. That's my general solution to the first differential equation from this worksheet. Let's go ahead and move on to the second question for this worksheet. Excuse me. This question is asking us to find the particular solution, which is the same as the specific solution. And this time, our equation is dy dx equals 7x squared over y cubed. And our question also tells us that x equals 3 when y equals 2. So that's going to be an initial condition that we can use to solve our particular solution. But before we can get a particular solution, we have to start by getting a general solution. And before we can get a general solution, we have to start at the very beginning by grouping our variables. So that's always going to be our first step, is to group our variables. So in this one here, I've got y's on both sides, and I have x's on both sides, and I have two fractions. So that's a really big clue that the best way to start trying to group my variables, and then I can check to make sure it worked, is to just go ahead and cross multiply. So I can get rid of both of my fractions, and I can make sure, and I can try to see if that's going to get all my variables together. So I'm going to have my y cubed times dy, which is wonderful. That's exactly what we want. And on the right, I'm going to have my 7x squared, and I'm going to multiply that by dx. So just one final check. My y's are together, my x's are together, my grouping variable step is done. Now that I've grouped my variables, I'm going to move on to my second step, which is to integrate both sides. So I'm going to integrate the left and integrate the right. On the left, my y cubed will go up one exponent, and we'll divide by, it's supposed to go up an exponent, so it's going to go to the 4, and then we're going to divide by that new number, y to the 4th over 4. On the right, we're going to have the 7 come down. X squared is going to become x cubed over 3, and I'm going to put my plus c on the right. So my integrating is done. I've got nothing to simplify, and I would solve for y at this point to find my particular solution. But what I'm going to do instead, I would solve for y to find my general solution, but I need to find a particular solution. So there are two different ways that we can do this, and I'm going to show you both of them, just so you know that it doesn't matter which one you decide to do. If I go ahead and try to find my particular solution now, I can go ahead and plug in my 2 for y. That brings me to 2 to the 4th over 4. And on the right, I'll have to plug in 3 for x, so 7 times 3 cubed over 3 plus c. This is going to lead me to a value of c. The second option that I have is to split this off and do a little simplifying first. So I've got y to the 4th over 4. Eventually, I'm going to want to solve this for y. So I am going to have to multiply everything here by 4. So I want to show you what happens when I do that step. If I multiply everything by 4, I end up with y to the 4th equals 7 times 4 is 28, 28 x cubed over 3 plus c. c times 4 is just c, so this is just plus c. And it looks like these are leading us in different directions, so let's see what happens in this step when I plug in my x and my y. So I'm going to plug in my y. It's going to give me 2 to the 4th power. And on the right, I'm going to have 28 times 3 cubed over 3 plus c. So I'm going to solve each one of them to see what it gives us for this value of c. Excuse me. On the left, I'm doing 2 to the 4th power, which is 2 multiplied by itself 4 times, which actually gives us 16. And I'm going to divide that by 4. So 16 divided by 4 is just 4 on the left. On the right, I have to do 3 cubed. 3 cubed is 27. I have to multiply that by 7 and divide it by 3, but it's easier to divide it by 3 first. So 27 divided by 3 is 9, and 9 times 7 is 63. Awesome. So to finish up this one, in order to get c by itself, we're going to subtract 63 from both sides. So on this side, we have negative 59. Negative 59 is c. On the right, if I continue solving this one, 2 to the 4th power is 16. Inside here, I'm going to do 28 times 27, which is a very big number. I can go ahead and do that 27 divided by 3, so I can do that first. So all I have to do is 28 times 9, which isn't so bad. And if I do 28 times 9, it's 252. So obviously these look very different, and it's okay, and I'll show you why it's okay. So my last step on the right is to solve for c, subtract 252 from both sides. I end up with negative 236. So these are very different c values, but if we continue the thread on both of these, once you get your c value, you can plug that back into the equation you got before, that general solution, so that you can continue solving for y to get to your final form. So here, this equation I was using was this one here. So I would do y to the 4th over 4 is 7x cubed over 3 plus negative 59. So it would be minus 59. On this side, this is the equation that I had gotten to find my solution. I would get y to the 4th is 28x cubed over 3 minus 236, right? So the left was minus 59, the right was minus 236, sorry. Okay. So to finish solving this solution on the right, all I have to do is undo this 4th power, and I can do that with a 4th root for both sides. So if I do that, I end up with y equals the fourth root of 28 over 3 times x cubed minus 236. On the left, before I can get y by itself, I have to get rid of this 4, which we already did in this step up here on the right. So I've reached the point where I have to do that on the left. So let's go ahead and multiply everything by 4. We get y to the fourth. 7 times 4 is 28. X cubed over 3. And 59 times 4 is 236. So we've reached the same point we were at earlier. We end up with the same number, even though we found a different value for c. So it doesn't matter when you find that value, whether you do it before you multiply by 4 or after you multiply by 4 to start getting y by itself, it's going to lead you to the same spot. So there is no time that's going to be too soon to go ahead and find that particular solution. So the last step for the left is to do my fourth root. So y is going to be the fourth root of 28 x cubed over 3 minus 236, no matter when you decide to solve for c. What I recommend is solving for c as soon as you're comfortable. So once you integrate and you simplify your equation, go ahead and solve for c. On the left here, it actually ended up being easier to solve for it sooner. If you would rather not deal with fractions, then you can go ahead and eliminate as many of those fractions as possible and then solve for c. You might have larger numbers, but if you're willing to deal with large numbers instead of fractions, that might be better for you. It's really whatever your preference is. But once you've integrated, you can go ahead and start solving for c. You don't have to get y by itself first. So that's the end of this video. We're going to pick up with question 3 in the next video.